Thank you. Thank you.
Yeah.
Thank you for accepting our invitation.
Yeah.
So,
just a minute, I will share my screen. Okay, I am audible, right?
yes, yes. Wait. I'll just have an introduction, then we can start. So, first of all, very good morning and welcome to you all for this 5 days FDP on advances in highway technology and traffic system. Welcome to the 5th day, session 1. Today we are with us is Dr. Abhijith B S. He's a engineering technical support mainly on geotextile at St. Gobain, Adfors. Dr. Abhijith is responsible for providing technical support to geotextile business for the Asia Pacific region. One of the important role is to provide solution through the use of GLASGRID in asphalt concrete layer to extend pavement service life. He has completed his Bachelor's of Engineering in Civil Engineering from JSS Academy of Technical Education in Bangalore. He had pursued Master of Technology in Transportation from NIT Surathkal. He has successfully defended his PhD thesis titled Investigation of Fatigue Behavior of Bituminous Concrete Mixtures from Indian Institute of Technology, Madras. He has published his research work in various journals, to name a few: International Journal of Pavement Engineering and Journal of Materials in Civil Engineering, ASC. So with this brief introduction, I welcome you, sir, to deliver today's session. Over to you.
Thank you, sir. Thank you for the introduction.
Yeah. You can share your screen.
Yeah. So it is almost an hour, right? I have 1 hour time.
Yes, sir.
Okay, you can see my screen?
Yes.
Okay, so good morning to all of you. I am a technical support engineer, as Professor introduced. So like I work for St. Gobain Adfors, and I give technical support to GLASGRID and other geosynthetic products. So today I'll deliver a brief presentation on use of GLASGRID and other geosynthetic products for improving pavement performance. So predominantly I'll cover GLASGRID and few portions on other geosynthetic products. So this is a brief outline. What is the challenge that we are facing today in terms of energy demand? What is the challenge that we are going to face in future? So I'll be explaining about that and the different types of payments, okay, and what are the different types of distresses. And predominantly I'll focus on cracks, fatigue cracking and other longitudinal cracks and all the associated cracks. And then I talk about why do you need a reinforcement interlayer to avoid cracks or to basically to retard the growth of cracks. Then I'll introduce about our product with the case studies, design, applications, and I'll briefly talk about other geosynthetic products. Okay, so this is the challenge that we are going to face in future. So the raw material requirement is going to increase by up to 2.5 times by the end of 2060 or 2050, and 12% energy demand. We need an additional 12% energy by 2030. The passenger transport will increase by 3 times. So we need to basically, what does this say? We need to optimize the materials. We need to optimize the materials that we have. We need to basically do not compromise on the design, but basically use less materials and attain the same design requirements. So that is what it says. Okay. So coming to the infrastructure, basically predominantly it's payments. Okay. So India is the second largest road network in India, road network across the world. So we need to focus on the payment, how to maintain it. Okay. What are the challenges that we face? What are the different types of payments and all those things? So the commonly used, which is like 95% or 90% of the roads, national highways, expressways, is of asphalt concrete pavement. Okay. So you will have 2 layers of asphalt mixtures in the top, one base course and a sub base course. This is what a typical cross section will have. It can have other variables as well, but this is what we see in most of the cases. So now when basically there can be a composite pavement as well, where there will be a concrete base and on top of it there can be an asphalt mixture layer. So here in this scenario, the cracks from the joints can come to the surface. So this is one way in which the cracks appear to the asphalt concrete overlay that is laid on top of concrete base. And there can be thermal expansion and contraction, which again leads to shrinkage cracks in the concrete disc and then comes to the surface through what is called as a reflection cracking phenomena. So this is one way of basically identifying the cracks. The second one can be in pure asphalt mixture layers. So basically due to the vehicle continuous movement of vehicle, repeated application of load, the tensile strain of the asphalt mixture exceeds the strength of the material, and cracks, bottom of crack propagates to the surface. So this is one phenomena wherein you again observe cracks. So as I said, it can be a reflective cracking coming from the concrete surface below, and there can be alligator cracks because of the excessive tensile strain at the bottom of asphalt mixture. There can be joint reflective cracks. The cracks can come from the joint. The cracks can come from the utility cuts that you have made, and improper subbase or settlement in the lower layers, and also due to temperature cycles, as I discussed. So how to rectify all these things? Okay. So we identified the three main mechanisms. One is the vertical shear, which is basically causing this particular damage. Bending is one more, okay, and then thermal movements. Okay, these are the three main mechanisms which are causing this. So how to basically retard the growth of this and reduce the maintenance activity? That is the challenge that we are going to address in this presentation. So without any interlayer, okay, the basically cracks from the bottom layer will propagate to the surface easily, as you can see here in this particular picture. And suppose if you have an interlayer like a GLASGRID, okay, it comes and hits the GLASGRID and changes the direction, okay, until so the crack will propagate until there is not enough energy to propagate further. Okay, so I can show you one example of one of the study of St. Gobain Adfors. So this one is basically without GLASGRID. Okay, I'll repeat, I'll just show it without GLASGRID, and this one is with GLASGRID. You can see how much resistance this can provide, GLASGRID can provide, how much increase in the tensile strain that it can take when compared to no GLASGRID. So this is what it is. Interlayer, what does interlayer do? You can see the crack initiation stage here, and it reaches the interlayer here, and then it propagates horizontally instead of vertically. So if you do not have an interlayer like GLASGRID, it will come to the surface. Okay, so this is the main lineup of our GLASGRID. We have many products, but I've just shown 4 different products here. One is the regular GLASGRID, which has a self-adhesive backing. It can be directly applied to old asphalt surface or leveling course, which is predominantly used in airport projects. And now we have a composite GLASGRIDs, basically, where a non-woven fabric will be attached to this GLASGRID. So it has 2 purposes. One is reinforcement, and in addition a moisture barrier. So I'll explain you briefly what is this 2 main functions that it serves. So when the weight of the non-woven fabric is basically greater than 135 GSM, that is when it gives the additional function of moisture barrier in addition to reinforcement. And we also have a patch grid where it can be used for local repairs, joint filling, pothole filling, and all those things. Okay, let us see what is this GLASGRID basically made up of. Okay, so these are made up of glass yarns, okay, whose basically melting point is greater than 820 degrees Celsius, and it has a polymer coating, a patented elastomeric based polymer coating, whose melting point is greater than 232 degrees Celsius. So we need this kind of higher melting point, because when it comes in contact with hot mix asphalt, okay, whose basically the mixing temperature will be close to 180, 190 in case of modified mixtures, it should not basically damage the grids or damage the coating or the junctions. So this is the main purpose of going with higher melting point coating. Okay, so when we have a self-adhesive one, we also have industrial pressure sensitive glue, so you can directly put it on top of a leveling course, this self-adhesive GLASGRID, and then go ahead with the paving operation. Okay, so these glass yarns are basically knitted together. This is the main difference compared to other GLASGRID products. It is knitted together with the thin polyester yarns. Okay, it is caught by needles to create a series of knots along the wall. Okay, so this preserves, this kind of knitting technology preserves the geometry or stability of the grid under the action of heavy loads, and also it will have integral joints. It prevents rupture of the coating as well. Okay, so this is what the product is made up of. Okay, so why do we have to choose GLASGRID over other products in asphalt reinforcement? So this is something which we need to know technically, because the basically the asphalt mixture in the top layer fails at a very less tensile strain basically. So the amount of tensile strain at which it starts initiating and propagating the cracks is very less. So we need a reinforcement where it can achieve the target strength, okay, target tensile strength at a very low strain level. Okay, so this is one example here. This is the simple plot of strain versus the tensile strength of three different products. One is GLASGRID, the other is the polyester material, polyester product, polypropylene product. Okay, so if you see here, the GLASGRID basically can attain the desired strength of 100 kilonewton per meter in 3%. Okay, this is what we need. It should attain the target strength in less than 2 to 3%, because this is the point where the asphalt mixture fails by tension. Okay, whereas this polyester and polypropylene, if you look at, so what happens is it can only achieve somewhere around 30 kilonewton per meter at the time of failure. So it will not provide enough reinforcement compared to GLASGRID. So this is something which we should know, because it should ultimately, whatever reinforcement we use in the top layer should serve the purpose. Okay, so what does this do? The whole thing, left image that you are seeing here is this is the initial construction cost for the highway, and there will be frequent maintenance activities, and then these are the routine maintenance activities and annual maintenance activities. There comes a big rehabilitation wherein you have to go with an asphalt mixture overlay. It can be a BC overlay or it can be DBM overlay, which are the two different layers in asphalt mixtures. So at least in a lifespan of 30 years, you may need up to 5 times or 5 to 6 maintenance cycles, big maintenance cycle. Whereas if you use GLASGRID plus asphalt mixture overlay, you are prolonging the maintenance activity by 1.5 to 2x easily. Okay, this is what it does. So it easily avoids 2 maintenance cycles, at least in a lifespan of 30 years. And at the end of 30 years, you will also have higher salvage value. Means the value of the asset will be higher because of higher remaining life that the asset will have. So this basically, the GLASGRID delays the maintenance cycles. Okay, now let us look into some performance testing that has been carried out on Adfors GLASGRID. So this is one study, a full-scale test that is conducted in France. So the aim was here to evaluate between the GLASGRID section and no GLASGRID section basically. So an 100 kilonewton per meter tensile strength GLASGRID product was used in one case, and what they did is they constructed from the subbase. They basically a 300 mm thick subbase, and on top of it a 20 mm BC was provided, GLASGRID was provided, and then a 50 mm BC again. So in this case, there is no reinforcement. The same construction happened parallelly, and it was subjected to a basically traffic with a standard axial load of 65 kilonewton. This thing load for almost 1 million cycles. So in this way, continuously at a speed of 45 kilometers per hour. So what we observed is the cracking appeared first on section without GLASGRID at 0.8 million cycles, means 8 lakh cycles, whereas there was absolutely no cracks until 1.2 million cycles when we had GLASGRID. Okay, so this is what it is. So no GLASGRID, the cracks appeared at 0.8 million, whereas at 1.2 million cycles, hairline crack or even lesser crack, you can see the chalk piece marks here. Okay, these are of unreinforced section. This is of the reinforced section. So this is an ongoing study in India. It is being carried out by IIT Madras and Rasta. Performance evaluation for GLASGRID reinforced pavement. This is a stretch here in Karnataka, basically Devihalli to HASSAN. So here the concessionaire used our GLASGRID product for this particular project, where there was a very severe alligator cracks. Okay, severe alligator cracks from the DPM and rutting as well. So they wanted to just mill the BC and put the GLASGRID, and then again 40 mm BC where the cracks have appeared till DBM. Whereas in the case where the distresses are only appeared on the surface, with BC, they just wanted to go with without GLASGRID, basically, just a conventional overlay. So this is what they did. The rehabilitation was carried out in 2017. A visual assessment has been carried out by IIT Madras and Rasta. So they see only hairline cracks and the bleeding of low severity at some of the GLASGRID section. The research is still ongoing, and section without GLASGRID appears to have medium to high severity cracks. You can easily see here. Okay, so the research will be carried out for 3 more cycles to come out with a better assessment. So this is basically fatigue testing, laboratory 4-point bending fatigue testing that is carried out in IIT Madras. So a 4-point bending test. Second, sorry. Thank you. 4-point bending fatigue test was carried out on asphalt mixtures reinforced with GLASGRID. Basically, the GLASGRID was kept at 2/3 depth from the surface. It will have somewhere around 63 mm or 53 mm thick beams, and the GLASGRID was placed at 36 mm, like 2/3 depth from the surface. And then strain controlled fatigue tests were carried out at 3 different strain levels: 400, 600, and 800 microstrain, and at a constant frequency of 10 Hertz. And fatigue life was basically analyzed using the raw data from the load and displacement data that they get. And basically, using different fatigue failure criterion, they found that the fatigue life of GLASGRID is at least 3 to 4 times higher. So this is the laboratory fatigue test. It is at least 4 times higher when you use a fatigue failure criterion like energy ratio or a conventional ASTO criterion, where they just say take a 50% reduction in the modulus from the initial modulus. This is again one study from Parma University in Italy. So here a 3-point bending test was carried out by applying a loading rate of 0.084 mm per second. So a reinforcing effect of GLASGRID was clearly seen from the force versus displacement curves. So you can see higher resistance to fracture for GLASGRID compared to no reinforcement section, and you can see highly concentrated strains below the interlayer. See, this is basically GLASGRID. So you can see that it's localized strain, basically concentrated strain. It does not come to the top layer, whereas without GLASGRID, it has easily come to the surface. And this one more way of checking whether this GLASGRID will have a proper bonding between the top layer and the bottom layer. What we use is something called as a Lutner shear test. Okay, so here constant cross-head displacement rates will be applied, and as per ZEC technical standards, it should have a minimum 15 kilonewton shear load for the products that is being tested. It was tested on different GLASGRID sections, and all tests meet the requirement as per the ZEC standards. When it comes to India, the Lutner test, bonding test, is ongoing. It is an ongoing process in IIT Madras, ongoing research funded by Saint Gobain. I'll just play this video as to how the testing will be carried out. Yeah. So this is how a Lutner shear test is basically conducted. Their interface will be created here, and the load will be applied only this particular direction, and the resistance it takes will be captured and compared with the control one. Okay, so this is the control sample that I showed. Similarly, the studies are ongoing for GLASGRID products, and we will get the results soon. So this is the GLASGRID not only basically enhance the fatigue life of bituminous mixtures, it also enhance the rutting life of bituminous mixtures. This is again a funded project by Saint Gobain to IIT Madras, where GLASGRID is placed at 40 mm from the surface. So the dimension of the slabs will be 300 cross 150 cross 50. 50 mm is the thickness, and GLASGRID is placed at 40 mm from the surface. A standard wheel load is basically applied, 700 Newton, which moves forward and backward on top of this GLASGRID reinforced bituminous mixtures at a rate of 26.5 revolutions per minute. And this rut depth will be captured with the help of LVDT at every 4 mm interval. And the tests were carried out at 60 degrees Celsius. So you can see that this is the no GLASGRID section, the black one. And this is of 2 different products with higher weight of monomer fabric composite GLASGRID has higher resistance to rutting. So nearly you can expect 15 to 45% increase in rut resistance of GLASGRID reinforced mixtures compared to unreinforced one. This is a similar study by North Carolina State University, where the GLASGRID was basically placed at 70 mm, 38 mm from the top of the asphalt mixtures, and more like mobile loading simulator was used, where an accelerated pavement testing device. It's an accelerated pavement testing device where it is subjected to 5,500 wheel applications per hour. So it will basically have total of 4 wheels, and each wheel will have a pressure of 700 kPa. It will again move forward and backward. So you can see the results here: control versus GeoGrids. Basically, there is a 25% increase in resistance of GLASGRID reinforced bituminous mixtures. Okay, so this is again one more study in USA from NCAT, basically National Center for Asphalt Technology. It's a 2.8 kilometer oval section that is basically made to capture the field performance. Basically, 2 sections were basically constructed: one with reinforcement, one without reinforcement. Reinforcement, by reinforcement I mean GLASGRID, St. Gobain Adfors GLASGRID. So after 6 years and 20 million ESALs, okay, no cracking was as appeared in the section where Adfors GLASGRID was there, and the cracking was observed. Basically medium to high severity cracks were observed along the entire unreinforced length of this particular oval section. Okay, and also after after this particular testing, the GLASGRID was taken from the road, and you can see that absolutely there was no damage to the GLASGRID product here. This is one more testing where we basically call it as damage test for installation. So during installation, we should ensure that the GLASGRID will not get damaged. Okay, that is the main purpose. Then only it can serve the purpose of reinforcement. So this is one test where the aggregates will be poured. Basically, the GLASGRID will be sandwiched between aggregates. This is the glass fibers without protective coating. Okay, it had 60% loss of strength, whereas Adfors GLASGRID, which had a protective coating, had up to only 10% loss in the strength. Okay, the next question you might ask is, okay, I am going to use GLASGRID everywhere. It looks like an interesting idea. Can we mill it for future? Yes, we can. Okay, it is not like polypropylene or polyester products. We can basically easily mill this products. You can see the glass fiber strands that are uniformly distributed in the milling material here. And there is a study that has happened in Europe, with our GLASGRIDs, glass fibers. The extracted basically glass fibers were put in with 0.5% of that was put in the asphalt granulates, which is nothing but RAP, with the RAP mixtures. And they found that the one with GLASGRID plus RAP, 30% RAP, had higher higher tensile, basically higher tensile strength, or what do you say, loading cycles to failure when a tensile testing was carried out. Okay, the next step is the design. Okay, so can we do the design with the GLASGRID? Yes. Okay, we have 4-point bending fatigue testing results from IIT Madras. This is a typical SN curve that you can see, which is basically strain level versus number of repetitions. As I showed earlier, fatigue testing was carried out at 3 strain levels by IIT Madras, and the fatigue life was computed using different approaches. And this is the SN curve that you are seeing. Using this, we will be able to find out something like a traffic benefit ratio. Okay, that is the allowable ESALs with GLASGRID with respect to allowable ESALs, equivalent standard axle loads, without GLASGRID. Okay, so this is easily obtainable with this SN plot for any given strain levels. Okay, so once we have the percentage increase in the resistance to tensile strain that comes at the bottom of the asphalt mixture, we can easily find out how much extra life that it can take, the GLASGRID can take, when compared to unreinforced one, as well as if you use GLASGRID, can we optimize the thickness? So those studies are also ongoing basically. So this is one case study where the design was implemented. You can see here severe cracks were observed in the field, and there were rutting up to 20-30 mm, in some cases up to 60 mm. Okay, so there were upheavals and all those things. So concessionaire approached us to basically give an alternative design with GLASGRID. So they already got a recommendation for cold in place recycling. So the recommendation was to remove the entire bituminous layer, put a cold in place recycling and new bituminous layers. So this is what the recommendation they had earlier before approaching us, which would have costed them easily 5,600 rupees per cubic meters. Okay, so in our case with the GLASGRID solution, we basically helped them to solve this at 1,176 rupees. So this is what we did. So we did not ask them to go with a complete removal of bituminous layers. Basically, we collected the information such as bituminous core samples, okay, the design reports that they have, the trial pits that they have taken. So what is the thickness of each layers, the FWD report, falling weight deflectometer report, to calculate the, to see the modulus, what is the modulus of the existing layers. And, cores were taken at multiple locations to see the, basically the addition between the asphalt binder and the aggregates at the bottom. So considering all those things, we just asked them to remove the top layer, the top 100 mm bituminous layer, which is completely distressed, and then provide a composite glass grid and basically new PC and DBM. So this is a significant cost saving compared to that particular design, savings up to 3 to 5 times, and there is no compromise on design requirements. We have basically many other case studies like this, where the concessionaires will come with an alternative with one conventional design, and we provide them an alternative glass grid design. Okay, so these are some of the applications. One second. Okay, yeah. So these are some of the applications. One is rehabilitation projects. There is a cracked surface. There is an existing cracked surface. So we don't want the cracks to come to the surface. We basically want to delay the process of coming. So if the regular one comes in 6 months to 1 year, we want this to go for 3 to 5 years. That is the purpose, so that we can delay the maintenance activity. That is where we can use GLASGRID. Then between the two new layers in a greenfield project. Okay, so if it is a low volume roads, you'll basically only have a small dense bituminous macadam, small thickness of dense bituminous macadam, and BC. You can sandwich between these two. Or if you have a high volume roads, you can sandwich between the two lifts of DBM. So with this, you are basically talking about enhancing the fatigue life from the beginning itself. Okay, so the cost might be a little high at the initial time, but you are looking at a prolonged duration for the maintenance activity. And you can also use it for RAP. Okay, so there are projects where in low volume rural roads we are trying to use RAP. So there we can use GLASGRID along with RAP, basically because the RAP is weak in tension. We all know that it is weak in, it is having lesser fatigue life compared to the virgin aggregates that is being used in hot mix asphalt. So for that, to basically increase the tensile strain resistance of the RAP mixtures, we can use GLASGRID. And now the other two interesting applications is cement treated base. So cement treated base, they recommend SAMI in IRC 37 2018, stress absorbing membrane interlayer. So one of the options we can use it is geotextile impregnated with bitumen. So we can use our composite glass grid. We have been using this composite glass grid in many of the SAMI projects where we have cement treated base. So the idea of SAMI is basically the shrinkage cracks that comes from CTB should not propagate to the surface, or basically to delay the process of coming to the surface. So that is where we have our application. Similarly, in the full depth reclamation projects, what they essentially do is they mill out the entire thing, whatever is there, and then provide cement stabilized base layer, and on top of it a bituminous layer. So we can provide it as SAMI there as well. So these are some of the installation pictures that we have. You can see this. This is the millet surface. We expect uniform milling, so that it will be easy for the application of composite glass grid. So this is the tack coat application. We strongly recommend VG10 unmodified neat bitumen basically for better addition of the glass grid to the surface. And this is the composite glass grid. This is our material. Okay, so you can see the paving process here. This is the mat basically after paving, and after the rolling application. So Adfors GLASGRID, it's a very sustainable solution because it improves the service life, reduces the life cycle cost, reduces the maintenance cycles, basically reduce the construction program, and reduced carbon emissions. There is absolutely minimizing the safety and minimizing the safety risk basically. And it is recyclable. The strength of GLASGRID plus RAP basically was higher, very high compared to one without GLASGRID. And we are also looking at effective usage of natural resource. So it can be used in greenfield projects, can be used in the rehabilitation projects as well. Okay. So now let us look into other geosynthetic products. We have polypropylene geogrids, which are used in basically to reinforce the unbound granular layers. So you can place it on top of subgrade or on top of a base layer or in between the base layer or in between the sub base layer. What does this do? Polypropylene geogrids, it basically reinforces the base layer and increases the modulus of the base or sub base layer wherever you are basically placing this. And with this, if you have an established modulus improvement factor, means how much modulus is going to be increased with the help of this polypropylene geogrids, you can reduce the thickness of the granular base and sub base. So it is as per the Codal Provision IRC SP 59 2019. There can be a reduction in consumption of natural resource, increasing the service life of the payments for the same thickness with geogrids. So, but what do we need? We need a well-established modulus improvement factor or layer coefficient ratio, for the GLASGRIDs. So we have that, and we give solutions for this particular scenario. Okay, so this is one example. So this is the conventional one. Okay, conventional one without geogrids. So it comes up to 660 mm from the subgrade, whereas with geogrids you can reduce it to 490 mm. So this is one picture where you are basically using geogrids with granular subbase. You can also use geocells. Again, IRC SP 59 it recommends usage of geocells to basically reduce the thickness. This is the conventional one. You can see a very thick one here, and whereas you can use geocells in the granular subbase, geocells in the granular base, and reduce the thickness of individual layers. You can also use geocells for erosion control or erosion protection. When it's filled with soil, completely confines the whole thing, and it reduces the erosion problem. Okay, we also have products for like geotextiles, basically, which is used for erosion control, again filtration, separation. Okay, this is a geocomposite that we have. So the geocomposites basically can be placed between the subgrade and the subbase. The water that is coming from the surface will basically come on, hit the geocomposites and flow in the lateral direction. So that is what it happens. And you have also a geotextiles where it can be used as a separation or a filtration, and you can also wrap it along the slope to basically control erosion. Okay, so you need to ask what should be the opening size, what should be the in-plane permeability, what should be the tensile strength, mass per unit area, tear strength, burst strength, puncture strength. So these all depends on case to case. So okay, you have to go to field, collect the soil sample, test it, what kind of soil it is, how much silt percentage is there, how much clay percentage is there. Depending on all the geosynthetic complete geotechnical report, you can come up with this solution, and we have that design expertise with us. Okay, so we have something called as a road patch material, wherein there can be potholes. You see severe potholes everywhere. Bangalore has become a hub of problem of potholes. So this is what it is. You clean the pothole first and basically put a cold mix asphalt on top of it, or you can also place an hot mix asphalt. And then we have a patch material, as you can see here, which is basically you can remove the disposable film and just directly place it on top of this thing. It has a reinforcement. So it basically what it does, it doesn't allow water to enter into the pothole region and further deteriorate as compared to the conventional one where there won't be any patch. So you can see that even after 6 months, the patch is going well in Indian scenario. Okay, so this is the to summarize the products, the geosynthetic products, and also the geosynthetic applications in infrastructure projects in India. We can use GLASGRID for asphalt layer reinforcement, but you need to be careful. You need to go and collect all the necessary information from the field, and also you need to have the testing that is required to be done with GLASGRID. So you should have a fatigue testing report, you should have a performance evaluation report, you should have a RUTTING test report. Okay, then only we can come up with a design considering the variables associated with it. Now you should have geogrids. Geogrids can be used in unbound pavement layers for reinforcement, can be used in railway track stabilization. So basically, the design factors that is required is you need a modulus improvement factor or a layer coefficient ratio, so that you can use it in ASTRO design, if not in basically Indian design scenario. So same thing with GeoCell. You need to have a modulus improvement factor. Then you can use it for stabilization. You can use it for reinforcement. And basically erosion control. Geocomposites, you can use it for drainage, but you should have the permeability. Okay, what is the inflow permeability, in plane permeability, out of plane permeability? So such parameters are required before giving the solution. And geotextiles, again, the opening size, what should be the opening size, and all the other parameters, tensile strength, okay, the permittivity, So that is when for each case we can propose with the geotextiles, and we have a road patch for pothole repair. So depending on the severity of the extent and severity of the potholes, we can provide a suitable product. So this whole thing basically extends the payment life significantly and provides 50% reduction in future investment costs such as maintenance rehabilitation over the life of an average road. Okay, so thank you. Any questions?
So thank you, Thank you, Dr. Abhijith, for your nice presentation.
Yeah.
So what we will do is we will take up some questions.
Okay.
I think one question is asked by Mr. Neeraj Singh.
Okay.
So the question is only one layer of GLASGRID is used and why only one layer?
Okay. So can I talk to Neeraj?
Yes, yes.
Okay. Hi Neeraj. So basically, can you just come with the question that you have in mind so that I can answer appropriately? Hello.
Hello, Mr. Neeraj Singh, you can unmute and answer. Is Neeraj Singh available?
Okay, anyway, I will answer to this question.
Okay.
We can use multiple layers of GLASGRID. Okay, so the only issue is the finance. Okay, because it is an additional cost in the initial stage. But when it comes to strength, you will get it. Okay, when it comes to payment life, it will extend. We can design it with multiple, in the sense, you can provide it between 2 lifts of DBM and between DBM and BC. Okay, so you can provide multiple reinforcement, and it definitely enhances the life. But I don't think financially it is of that much beneficial, in the sense you have to spend at least 30% of the additional cost, initial construction cost. That is the only constraint.
Okay. Second question what is asked is, what is the difference between Gobain and Adfors GLASGRID, and why is the GLASGRID not brittle, being made of glass?
What is the second question?
What is the difference between Gobain and Adfors GLASGRID?
No, Gobain Adfors is same. Adfors is a business unit of Gobain. We call it as Gobain Adfors GLASGRID.
Okay.
Yeah.
Now, another question is, what is the thickness of GLASGRID?
It will come to up to 3 mm, 3 to 5 mm this range. The composite glass.
Okay. Now, another question is with respect to design procedure. That is, up to what thickness you have to lay this?
So minimum thickness of asphalt mixture overlay on top of composite GLASGRID shall be 40 mm.
Okay.
Should have a 40 mm thickness.
Okay.
And also the composite GLASGRID that you are putting should have a proper adhesion with the existing surface. If it is a rehabilitation project, with the existing surface, it should have a proper bonding. So that is why we recommend DG10 tack coat. Okay, and then on top of it, with the asphalt mixture overlay that you are putting, it should have the bonding. Then only it acts as a single layer. Otherwise, it acts as a monolithic layer and doesn't serve the purpose.
Oh, another question by Deepti Kanda.
Okay.
Can we use GeoGrid in reclaimed asphalt concrete pavement?
Yeah, GLASGRID can be used. GeoGrids, no, because technically I did show in one of the slides. I'll just move to that slides. See, this is what it is. GeoGrids means it will be either polypropylene or polyester. Okay, so the tensile strain that it will have at the peak strength of 100 kN per meter will be around 10%. Okay, so basically the wrap mixtures, it will fail at very low strain, tensile strain. Okay, it is very weak and it fails in a very low tensile strain. So you need a higher strength at a lower strain levels. Okay, so if you look at 3% strain is at which the wrap fails, then the GLASGRID will attain this 100 kN per meter there and gives the maximum reinforcement. Whereas if you look at polypropylene or polyester, you will only get 20-30 kN per meter, and it may not serve the purpose that much.
One more question from Mr. Neeraj Singh. The question is GLASGRID readily available for academic studies?
Yeah, definitely. We encourage. You can see that we have an ongoing study at IIT Madras. We have a study that is already been conducted by IIT Madras, and we have a study that is given to BITS Pilani. Okay, so we are always open, in basically sharing our product, and we are also interested to see what kind of research they do and encourage it. Yeah.
Another question, what about the cost of this material?
I am a technical person, so
Okay,
you can always basically talk to the.
Okay.
I can share
Now,
the contact of the business source. They can contact them. Yeah.
okay. Now, another question is, in one test, you have mentioned that a test has been
Yeah.
conducted at 60 degrees Celsius.
Yes.
Why it is so? Because normal pavement temperature comes around maybe 45 to 50. So why it is at 60 degrees Celsius?
Yeah. So basically, the air temperature, okay, the ambient temperature, if it is 35-40, the pavement temperature will be 65-70.
Okay.
Okay. So that is the reason why that at that particular high temperature, like 60-70, is the pavement temperature, not the ambient temperature. At that particular temperature, when the heavy truck moves at a very low speed, okay, there is a problem of significant rutting. So that is why we wanted to evaluate for a control mixture with GLASGRID at higher temperature.
Okay. So I think let me check any questions there. I think since no question is there, I think we can end the session.
Yeah.
So on behalf of the department and college, I once again thank Dr. Abhijith to accept our invitation and deliver a important session on glass grids in payments.
Yeah.
Thank you from our side.
Thank you, Professor. Yeah.
Now, for participants, next session will start exactly at 11:45. So I request all you to join around 11:30. Thank you.